So this video is going to be about quadratic equations. So what is a quadratic equation? Well, that's essentially a formula which looks like this, which is ax squared plus bx plus c equals to 0, where a, b, and c are all real numbers, and b is equal to 0, c is equal to 0, and a is equal to 1, and x squared can be represented by k, where x is equal to plus minus the square root of k. Now for solving quadratic equations by factorization. So as you can see here, we have a quadratic equation where it's ax squared plus bx equals to c. Then that can be rearranged into ax squared plus bx plus c equals to 0. That c should actually be a negative c because you're moving it over, which then can be factorized into x equals to plus minus a and x equals to plus minus b plus c equals 0. And this is because whenever a or b are positive or negative are not specified, meaning that they could be either of those two. And this means that x plus minus a equals to 0 and or x plus minus b equals to 0 because one of these two have to be 0. Now for an example of this, you have x squared plus 3x equals 28. Now first you want to rearrange this into a normal quadratic equation, so you get x squared plus 3x minus 28 equals 0. Then you want to factorize this by splitting, so you get brackets x minus 4 and in brackets x plus 7, because plus 7 minus 4 equals 3, and 4 times negative 4 times 7 equals 28 equals to 0. And this means that either x minus 4 equals to 0 and or x plus 7 equals to 0, meaning that either x is equal to 4 and or x is equal to 7. One rule which can be important to remember is that a divided by b equals c divided by d can be rearranged into ad equals bc. Then you, of course, simplify it, so you get x squared plus 5x equals to 36 minus 4x. Then you want to rearrange that into your normal quadratic equation, so you get x squared plus 9x minus 36, because your negative 4x over here becomes positive when you put it over here when you want to remove it from this side. So it becomes 9x, and that equals to, and all that equals to 0. Next you factorize by splitting again, and as you can see, negative 3 times 12 equals to negative 36, while 12 plus negative 3 equals to 9, which is why this makes sense, equals to 0. And this means that either x minus 3 equals to 0 and or x plus 12 equals to 0, meaning that x is either equal to 3 and or it's equal to negative 12. Next, there's solving quadratic equations by completing the square. An example of this would be x squared plus 2x minus 2 equals to 0. What you want to start by doing is you want to rearrange this into x squared plus 2x equals to 2. You want to move the c value from over here over to the other side of the equal sign. Then you want to add the b value divided by 2 to both sides, and since you're doing the same thing to both sides, you're not changing the equation, making this mathematically legal. And then you want to put that in brackets and square it. So you end up with x squared plus 2 divided by 2, because 2 is our b value, and that squared plus 2x equals to 2 plus 2 divided by 2 squared. Then that can be simplified into x plus 1 squared, because 2 divided by 2 is just 1, plus 2x equals to 2 plus 1 squared. That can then be factorized on this side into x plus 1 squared in brackets, and this on this side can be simplified into 3. Next, you want to simplify the entire equation, so you get x plus 1 equals to plus minus the square root of 3, because you're moving the squared part. Then you isolate x, so you get x equals to plus minus the square root of 3 minus 1, meaning that x is either equal to the square root of 3 minus 1 and or x equals to the negative square root of 3 minus 1. For another example here, you can have x squared minus 4x plus 6 equals 0. First, you want to start with moving c over to the other side of the equation, the equal sign. So you get x squared minus 4x equals to negative 6. Then you want to do what you did again on up here, where you add the b value divided by 2 in brackets squared to both sides and make still keeping the equation equal. So you end up with x squared plus 4 divided by 2 in brackets squared minus 4x equals to negative 6 plus 4 divided by 2 squared, or in brackets squared. Next you simplify, so you get x squared plus 2 squared minus 4x equals to negative 6 plus 4. Then you factorize this on this side and you simplify what's on the other side, so you get x minus 2 in brackets squared equals to negative 2. Then you simplify once again, so you get x minus 2 equals to plus minus the square root of 2. And then lastly, you isolate x, so you get x equals to plus minus the square root of 2 plus 2. And that of course means that x is either equal to the square root of 2 plus 2 and or equal to the negative square root of 2 plus 2. So lastly, we have the quadratic formula, which you can see down here. But to understand the quadratic formula, we first need to know how we arrive at it. So you start with a normal quadratic equation here. Ax squared plus bx plus c equals to 0, where a, b, and c are all real numbers, and a is not equal to 0. What you eventually want to do is isolate x so you can have a formula which automatically can give you x if you input all the other values in the right way. So to start with that, we will divide everything in the formula or the equation with a. So you get ax squared plus bx plus c, all that divided by a, equals to 0 divided by a. That ends you up with x squared plus bx divided by a plus c divided by a equals to 0, because when you divide 0 by something, it just still equals to 0. Next, you want to start by moving the c divided by a to the other side, so you end up with x squared plus b divided by ax equals to negative c divided by a. Next, you want to add bx divided by a divided by 2x to both sides, keeping the equation equal. So you end up with x squared plus b divided by a divided by 2x squared, all that in brackets squared, plus b divided by ax equals to b divided by a divided by 2x squared in brackets squared minus c divided by a. Then you simplify, so you get x squared plus b divided by 2a, because the x here and the x up here cancel out. So you get b divided by 2a in brackets squared plus b divided by ax equals to b divided by 2a in brackets squared minus c divided by a. Next, you want to factorize and also simplify, so you end up with x plus b divided by 2a in brackets squared equals to negative c divided by a plus b squared divided by 4a squared. Then you simplify once more, so you get x plus b divided by 2a in brackets squared equals to b squared minus 4ac divided by 4a squared. This is also what's going to end up being the discriminant later on, but it's not quite there yet. Next, you simplify again, so you get x plus b divided by 2a equals to plus minus the square root of b squared minus 4ac divided by 4a squared. Then you simplify what's on this side once again, so you end up with b minus 4ac, the square root of that, divided by just 2a. This square root does not cover the 2a down here. And then you can finally isolate x, so you get x equals to negative b divided by 2a plus minus b squared minus 4ac, the square root of that, divided by 2a. And then you can finally end up with the quadratic formula by simplifying it into x equals to negative b plus minus the square root of b squared plus 4ac divided by 2a. It can be represented by delta, or the triangle here. And it can tell you essentially what x can be just from the values you have already. So if the discriminant is less than 0, it means that there's no real solution, as you can't take the square root of a negative number. If the discriminant is equal to 0, it means there's only one solution, which is negative b divided by 2a. And if the discriminant is over 0, it means there's two solutions, which is either negative b plus the square root of the discriminant divided by 2a, or it's negative b minus the square root of the discriminant divided by 2a. So lastly, here's an example of how you would use the quadratic formula. So here you have a quadratic equation, which is 2x squared minus 24 plus 60 equals to 0. We essentially just plug that into our discriminant formula, which is b squared minus 4ac equals to the discriminant, meaning that negative 24 squared minus 4 times 2 times 60 equals to the discriminant, meaning that this simplified is equal to 576 minus 480 is the discriminant, meaning that 96 is the discriminant. As you can see, 96 is more than 0, meaning that there's two solutions, which you can see down here. Putting all of our values into our quadratic formula, you can see that x is equal to negative 24 plus the square root of 96 divided by 2 times 2, or it's equal to negative 24 minus the square root of 96 divided by 2 times 2. And as you can see, you essentially just simplify and simplify and simplify all the way down, and end up with x equals to 6 plus the square root of 6, and or x is equal to 6 minus the square root of 6. An example of a quadratic equation can be seen here, which is 2x squared plus 1 equals to 15, which can then be rearranged into 2x squared equals to 14, which can then be rearranged into x squared equals to 7, which can then be rearranged into x is equal to plus minus the square root of 7, because you simplify x into x squared into x, meaning that you also have to take the square root of the other side. Another example here is 2 minus 3x squared equals to 8, which can then be rearranged into 3x squared equals to negative 6, which can then be rearranged into x squared equals to negative 2, which means that there's no solution, as you can't take the square root of a negative number, because no two numbers of the same numbers multiplied together can be equal to a negative number. Another example here is x minus 3 in bracket squared is equal to 16. You simplify that into x minus 3 is equal to the plus minus the square root of 16. Then you take the actual square root of 16, which is equal to either plus minus 4 plus 3 equals to x, and that can then be sent into either x is equal to 7 and or x is equal to negative 1, as 4 plus 4 plus 3 is equal to 7, but negative 4 plus 3 is equal to negative 1. Lastly, we have this example, which is x plus 2 in bracket squared is equal to 11, which can then be simplified into x plus 2 equals to plus minus the square root of 11, which then means that x is either equal to the square root of 11 minus 2, or x is equal to the negative of square root of 11 minus 2. This is wrong. Next, we have the Null Factor Law, which is essentially that you can have two variables, s and t. If you multiply those together and it's equal to 0, it means that either s is equal to 0 or t is equal to 0, which is why I said and or earlier here. An example of this is this equation here, where 3x multiplied by, in brackets, x minus 5 is equal to 0. 3x is our s value, and x minus 5 can be our t value, which means that either 3x is equal to 0 or x minus 5 is equal to 0, which means that x is either equal to 0 and or it's equal to 5.